And we can still have partials of a second here when multiplying out. Once again, if we multiply our 0.413 times our 60, we get 24 and some change here. And whatever the change is, we take that and multiply that by 60. Whatever our change is here, we multiply that by 60, and we can have a partial of a second, and that's fine. There's not any microseconds that we're going to be dealing with here. We can just do a partials of the second. Problem we run into in the idea of dealing with degrees is in higher level mathematics, degrees fall apart. When you get into a calculus world, you start dealing with derivatives and integrals and evaluating the integrals and working with degrees. Mathematics falls apart. So what we have to have is we have to have another way of being able to deal with the idea of degrees. And that's the idea of radians. When we deal with radians, we work with what is called a unit circle. And when you're dealing with a unit circle, this is a circle that has a radius of 1 unit. A unit circle is a circle with a radius of 1 unit. Now that 1 unit could be 1 inch, 1 foot, 1 mile, 1 centimeter, 1 yard. Whatever 1 is for you, it's going to be 1 unit. And when we talk about the circumference of a circle, that's the distance around the circle. When we work with radians, this is the arc length on a unit circle. We're talking about an arc length on a unit circle. For a specific central angle. It's the arc length on a unit circle for a specific central angle. It's a portion of the circle in the interior of the central angle. Arc length on a unit circle for a specific central angle. It's the portion of the circle in the interior of a central angle. When we talk about a circle, the definition of a circle is a set of points that are equal distant from a given point. A set of points equal distant to a given point. So when you look at a circle, the idea of a circle here, the circle, we have a given point here. The circle is this stuff right here. This is the circle. This here is not the circle. That's the interior of a circle. But when you talk about a circle, if we think about this in pizza ideas, it's not a bad idea. A circle is the outer edge of the crust. The circle, in regards to a pizza, is not the good stuff. Okay, it's that outer edge of the crust. The interior of the circle is the good stuff that we eat. So when you talk about a circle, you're talking about this outer edge of the crust, these points here that are equal distance from a given point. Well, we have some ideas that we're going to talk about here that takes us back into geometry. The idea of a central angle. By definition, a central angle is an angle whose vertex is at the center of the circle. So when you talk about a central angle, you have a vertex the vertex of the angle is at the center. The vertex of the angle is at the center of the circle. That is by definition what a central angle is. The vertex of the angle is at the center of the circle. So when we look at a central angle, here would be your central angle. Why? Because the vertex of the angle is at the center of the circle. The radians is the arc length in the interior of the central angle. So your radians is this right here. This is your radians. It is the measure of that arc length. It's the measure of the arc length of the central angle, the interior of the central angle. We have a circle. We want to calculate the circumference of the circle, the distance around the circle. How do we calculate the circumference of a circle? The circumference of a circle. Anybody remember? The circumference of a circle. The distance around. Pardon? Pi times the diameter. That is correct. You have pi times the diameter or 2 pi r. Because if I take 2 times the radius, we get the diameter. So you have pi times the diameter or 2 times pi times the radius, 2 pi r. Well, what we have here is we have a circle, and I have a bunch of rays coming off of that. If we take a look at a rotation of a ray, which is by definition of an angle in trigonometry, if I would take a ray and rotate it the entire way around the circle. Okay, so I started here and I rotated here. What would be in the interior of that angle would be this entire distance. because I'm dealing with the amount of rotation here. So what's in the interior of this angle is this distance right here, which is the circumference of the circle. So my arc length that I'm dealing with here, if I rotated 360 degrees, the amount of arc length that we have here is the entire circumference of the circle, which is 2 pi radians. Because my entire circumference, if I put the value of 1 as my radius, the circumference of the circle is 2 times pi. And if I want to, I can multiply pi as 3.14 to approximate a circumference to be 6.28, but that would be approximate depth or approximate value. Radians are typically used or are left in terms of pi if possible, because every calculator has a pi button. Every calculator has a pi button. Everybody knows that the value of pi is 3.14 approximately. Or hopefully we know that. So the arc length that we have here is the entire circumference of the circle. If we take the ray and we rotate it just to here, we have rotated 180 degrees. The arc length that is in the interior of the circle is this arc length right here, which would be how many radians? Well, if I go the entire circle, I go 2 pi radians. If I go only 180 degrees, that's half the circle. How many radians have we gone? How many radians would that be? Jack?
1
Pi radians, 1 pi. We could take the 2 pi divided by 2. This would give us pi radians. So if I go 180 degrees, this is also the same as pi radians. If we only rotate up to here, which gives us 90 degrees. How many radians would be 90 degrees? Oh, and how many degrees would be 90 degrees? 1/2. Not just 1/2. 1/2. Now 1/2 rate, not just 1/2 radians. You're missing something here. There we go. This is 1/2 pi, or pi over 2 radians. Because we're taking half of pi. And once again, we can approximate that to be 3.14 divided by 2 and get an approximation there. But we can leave things in terms of pi. And once again, that's generally accepted in terms of pi. What if we rotated this 60 degrees? How many radians would be 60 degrees? Well, if I went 90 degrees, that would be pi divided by 2. What would be 60 degrees? Well, the key idea is to think about the idea of 180 degrees. 60 degrees, how many radians would be 60 degrees? 1/3 or pi over 3 radians. This here's a key idea. If I know 180 degrees is pi radians, what do you have to do to 180 to get to 60? Well, I can divide that by 3. So I'm going to take pi and divide it by 3. If we only rotated this 30 degrees, 30 degrees would be how many radians? 1/6. Not just 1/6, 1/6. There you go. So we have pi over 6 radians. The last one that we'll look at is 45 degrees. "45 degrees would be what in terms of radians? Don? 1/4 of pi over 4. A ratio or a proportion that we can utilize to convert degrees to radians and radians to degrees. First off, when we're dealing with degrees and radians, we are now going to use letter variables. Most of the time we're going to be using x. When you have degrees, when you're dealing with degrees, you have your theta and your alphas for your angles. When you're dealing with radians, you're going to be using x's or y's, typically x. A ratio that we can use to convert degrees to radians and radians back to degrees. Pi over 180 will equal x number of radians over theta degrees. Pi over 180 is equal to x radians over theta degrees. Theta goes with the 180 degrees, x goes with the pi radians. And once again, when we have things in terms of pi, and we want to convert them to degrees, the key idea to remember is pi radians is equal to 180 degrees. So when I have things in terms of pi here, it's sort of easy to convert to degrees, because we could just take our 180 and divide it by 3. When you have the value of pi in there, you can just substitute 180 in for pi. And that will take us into degrees form. Pi over 6 would be 180 divided by 6, 30 degrees. And this gives us our 45 degrees. These are also key values to look at when we're dealing with conversions. We'll go through an easier way of dealing with this here in a second. If I have 180 degrees, I want to convert this into radians. We have pi over 180 is equal to x radians over 150 degrees. Now, once again we are converting to radians, we want to leave things in terms of pi. So we have a proportion to solve here. We can cross multiply and divide. Now, once again, we want to leave things in terms of pi. So we have 150 pi over 180. We can simplify this by canceling zeros out. And it leaves us 15 over 18. And we can take 3 out of top and bottom. This will give us 5 pi over 6. Now, a couple different ways of dealing with this. If you want to do the easy way out, you could put into your calculator 150 divided by 180. Type 150 divided by 180 into your calculator. Hit your math button. Hit your math button, hit enter, hit enter. And what it will do is it will convert you and simplify your fraction down to 5/6. So you have your 5 pi over 6. That's the easy way out. If you want to advance yourself into your mathematic mental world, and this is typically what I do, I look at which one of these I can multiply by a value to get my angle. 150 degrees. I can multiply 30 by 5. I can multiply 30 by 5 to get 150. So I can multiply this by 5 also to give me 5 pi over 6. So if I take a look at 300 down here, I could do my cross multiplication and take my 300 divided by 180, hit your math button, hit enter. Or I can multiply by 300, cancel out zeros, and I have 30 over 18, divide 6 out of top and bottom. I can do it either way. Or I can look at which one of these can I multiply by a value. What can I multiply by a value to get my value of 300? And once again, this is sort of going through the idea of mental math and not depending on the calculator as much. I can multiply 60 by 5. If I multiply 60 by 5, that will give me my 5 pi over 3. And once again, if you click it back to your calculator, 300 over 180, hit your math button, hit enter, you get your 5/3, so you have 5 pi over 3. Go ahead and do the next 250. Now, none of these are multiples of 30, 60, or 45. Check your answers with somebody around you. Justin, what do you have for the first one? 200 degrees. 10 pi over 9. Once again, if you use your proportion here, you can cancel out your zeros. You're left to 20 over 18. You can take 2 out of top and bottom to give you 10 over 9. 50 degrees. Emily, what do you have for 50 degrees? 5 pi over 18. And once again, if you want to, you can click it into the calculator. Okay, when we have the values of pi, I want to change into degrees. Once again, it makes it a little bit easier when you have the value of pi. To simplify things, once again, if I take 2 times 180 divided by 3, I can just substitute my 180 in for pi. And yes, you can multiply 2 times 180 divided by 3 in your calculator. Or you can think of it a different way. I can maybe do my division first, 180 divided by 3, which is 60, and then multiply that by 2. And you can do the mental math a little bit more. Numbers get a little bit smaller. Go ahead and do the rest of them. Pi over 12, Sophia, what do you come up with? 15 degrees. 5 pi over 3, Beta Hampshire, what do you come up with? 300 degrees. And 9 pi over 4, Mike, what do you get? 405 degrees. Once again, radians are important because the upper level mathematics, when you get to that calculus level and beyond the calculus level, and you work into upper level engineering ideas, you don't have degrees there anymore. You don't measure things in degrees. You measure things in radians because your calculations are done in radians, and mathematics don't break down in radians. Because all we're doing now when we change things into radians is we're just changing it back into an XY coordinate system, okay, which is very comparable to upper level mathematics, calculus, and upper level physics, engineering, chemistry, any type of your upper level sciences deal with the idea of radians. They don't deal with the idea of degrees and measurements. So the ideas of radians is important because everything at the upper level of mathematics is based on that. Questions you have? All right, I gave you a worksheet yesterday. I asked you to work on the back side of that. That was just conversions of degrees, minutes, and seconds. The front side is dealing with the idea of radians. I'll give you the last 10 minutes here to be able to work on the front side there in regards to the radians.